Hi class. In this lecture, we're going to continue in chapter 12, talking about circles and other conic sections by moving into section 12.6. And it's a short section on about what we call locus. So our objective here is to draw and describe what we call a locus. All right, so first off, what is a locus? A locus is a set of points, all of which meet a standard condition. So I'm going to give the condition, all right, and it could be any condition, and then we're going to talk about like basically what shape forms from those locus, right? So loci is the plural of locus, and we can use the description of a locus, as I said, to sketch a geometric relationship. All right, so let's do an example. So what is a sketch and description for each locus of points in a plane? All right, so let's talk about all the points in a plane 1 inch from a given point C. Right? And then another one is we'll talk about the points in a plane 1 inch from any line segment AB. All right, so the first one here, C. All right, so let's start by drawing a point C and sketch several points 1 inch from C. All right, keep doing so until you see a pattern and draw the figure the pattern suggests. And what we see here is the locus is a circle with center C and radius 1. So I put the center C, and then it's just all the points 1 inch from it. Well, that point is 1 inch from it. That point is 1 inch. That point is 1 inch, 1 inch, 1 inch, 1 inch, 1 inch, and so on. And you can see that it's really just a circle. All right, and that's what I'm talking about with what locus are. Locus are is that description, okay? And then we're going to sketch that description. So part B, all right, let's sketch several points on either side of AB. So here's the line AB. And as I go from a long line AB, this point is 1 centimeter, this point is 1 centimeter, this point is 1 centimeter, all are 1 centimeter from the line AB. But then when we get to the end point here, this point, this point, this point, this point, this point, and the same thing with B, this point, this point, this point, this point, they're all still 1 centimeters doing so. So the locus is a parallel segments here, this segment and this segment from AB, and it looks like two semicircles, with the semicircles have points A and B on them. All right, so we can use locus description for geometric terms. So the locus of points in the interior angle that are equidistant from the sides of the angle is the angle bisector, right? Like you see here, right? So this locus is all the points that are equidistant from each side, like so, right? It's an angle bisector. And then in a plane, the locus of points that are equidistant from a segment's endpoints is what we call the perpendicular bisector, right, of the segment. So, like as you can see, like this point is equidistant from this point. Same on this side as we go here. This point is equidistant from here and here, so on. So it has to be the perpendicular bisector of the segment. All right, let's do another example. So what is a sketch of the locus of points in a plane that satisfy these conditions? Okay, so the points equidistant from intersecting lines K and M, right? And the points 5 centimeters from the points where K and M intersect. All right, so we start with intersecting lines K and M. All right, make a sketch to satisfy the first condition, then sketch the second condition and look for points in common. So I have two conditions here, and I want the locus is the geometric relationship that satisfies both these. All right, so first thing I did, I sketched the points in a plane equidistant from K and M. All right, these points form two lines that bisect the vertical angles formed by K and M. Right, so this right here and this right here satisfy the first condition. All right, and as the black lines here are K and M. And then separately, let's sketch the points in the plane 5 centimeters from the point where K and M intersect. Well, that's just a circle like this. So when we put it all together, all right, to locate the point or set of points that satisfy both conditions, we look at the intersection of our two sketches, and it really is, the locus is just the 4 points A, B, C, and D, right? It's not the entire circle, it's not the two lines, it's just those 4 points right there. All right, let's talk about in space, all right? So like in three-dimensional space. So what is the locus of points in space that are C units from a point D? And what is the locus of points in space that are 3 centimeters from segment AB? Well, the locus here for part A is a sphere with center at point D and radius C units like this. And remember, because it can go in and out and up and down, it's a sphere. And then what is the locus points in space that are 3 centimeters from segment AB? Well, as you can see, you're going to have to go in space like this. So the locus is a cylinder with radius 3 centimeters and a center line like this.